Welcome to the CosmoX channel. The speed of light is not just a number. It is a fundamental limit holding the world back from chaos, without which the very structure of the universe would collapse. We are used to calling it a limit, a barrier, a restriction, but in reality, it is the only shield preventing the destruction of the very foundation of cause and effect. At this limit, time stops, and the vacuum turns into an invisible fiery barrier, crossing which would mean the collapse of all existence as we know it. Today we will analyze why the speed of light serves as the foundation for all reality and why surpassing it would destroy the world familiar to us. Before delving into this mystery of nature, imagine a journey to the very heart of existence. Imagine yourself standing on an endless flat expanse. Directions are limitless, and it seems that you could accelerate infinitely. The more energy, the higher the speed. It would seem there are no limitations. But the universe is arranged differently. At a certain mark, an invisible obstacle appears, not stone or metal, but something much deeper, woven into the fabric of space and time. This is the speed of light, 300,000 kilometers per second. The closer you get to it, the more strongly the cosmos resists your acceleration. At first, this puzzle seemed like merely an engineering challenge. More energy means more speed. But in the 20th century, physicists revealed a terrifying truth. The speed of light is not just a technical limit, but a law of nature, a mechanism without which reality could not exist. If not for this restriction, causes would follow effects, time would flow backward, logic would collapse, atoms would disintegrate, and life would be impossible. Everything would turn into formless chaos. The speed of light is not just the limit of motion. It is the boundary between existence and non-existence, the edge of being itself. Today we will find out why this boundary is insurmountable not only from a technical standpoint but also from a logical one, what happens to those who try to approach it, and why tearing down this wall would destroy the universe. Let us start our story with the earliest attempts by humanity to understand, how fast does light really travel? For a long time, the world believed that light propagates instantly because we open our eyes and immediately see the surrounding space. Light a torch, and the light instantly illuminates the cave, without any delay. Ancient philosophers believed that light was a special substance that did not require time to spread. It was simply present everywhere at once. However, the thinkers of that era, including Aristotle, could not avoid questions about the very nature of light, although they did not have precise methods of measurement. The first to doubt the instantaneous speed of light was Galileo Galilei in the 15th century. He proposed a simple but ingenious experiment. Two observers positioned on the tops of hills several kilometers apart, each with a lantern. The first would turn on his light, and as soon as the second saw it, he would turn his on in return. The first would record the time between turning on his light and receiving the reply. Galileo repeated this experiment near Florence but was unable to detect any delay. It was either zero or too small for his instruments. The speed of light turned out to be incomparably higher than the possibilities of those measurements, but the very formulation of the question was a breakthrough. What if light is not instantaneous at all? Real progress came only in the year 1676 thanks to the Danish astronomer Ole Romer, who observed the satellites of Jupiter, especially Io, the closest large moon to the planet with a reliably predictable orbital period. Romer noticed a strange phenomenon. When the Earth was approaching Jupiter, the moments of Io's eclipse came earlier than expected, and when it was moving away, they were delayed by almost 22 minutes over 6 months. It was logical to assume that light needs time to cover the distance from Jupiter to Earth, and this difference was due to the change in distance by about the diameter of Earth's orbit, about 300 million kilometers. By dividing the distance by the delay, Romer gave the first estimate of the speed of light, about 220,000 kilometers per second, which for that time was astonishingly close to the modern value of 300,000 kilometers per second. The most important thing Romer proved: light travels at a finite speed, not instantaneously. This discovery completely changed the view of the universe. If light is not infinitely fast, that means we see distant objects not in real time, but as they were in the past. Light from the sun to Earth travels for 8 minutes. So we observe the sun with a delay of 8 minutes, and if it suddenly went out, we would find out only after this time. From the nearest star Proxima Centauri, light travels for 4 years, which means its image is a look into the past 4 years ago. The farther into space, the deeper into time. In the 10th century, scientists began to realize the true nature of light. James Clerk Maxwell unified electricity and magnetism in a single theory of electromagnetism. His equations described the mutual generation and interaction of electric and magnetic fields, and from this complex mathematical apparatus unexpectedly followed one surprising conclusion: these fields can propagate through space in the form of waves. The speed of these waves turned out to be not accidental. It directly depended on the fundamental constants of electricity and magnetism. Maxwell calculated this value and discovered that it matched the known speed of light measured in experiments. This was a real breakthrough. Light is nothing but an electromagnetic wave. Oscillations of the electric field generate magnetic fields, which in turn create new electric oscillations. The wave propagates through space. The speed of this wave is determined by the properties of the vacuum, which conducts electric and magnetic fields identically for all types of electromagnetic radiation, from radio waves to X-rays and visible light. However, one question remained: relative to what does this wave move? Sound requires a medium for propagation, air. Water produces waves only on its surface, but light? In the 19th century, physicists assumed that all space was filled with an invisible substance, the ether, which serves as a medium for light waves. The Earth, moving in its orbit, was supposed to pierce the ether, creating the so-called ether wind, which would change the speed of light in different directions, faster along the direction of movement and slower against it. It was precisely this effect that Michelson and Morley tried to detect in the year 1887 with the help of an ultra-precise interferometer, which split a ray of light into two at a right angle and then recombined them. If ether existed, the device should have registered differences in the speed of light, but the experiment showed a complete absence of changes. The checks were repeated many times at different times of the year, with various positions of the Earth, and everywhere the result was the same: no ether wind. The speed of light remained constant regardless of the direction and movement of the observer. This turned out to be a paradox. We are used to the fact that speeds are additive, whether it is cars on a road, but light, despite moving towards you, maintained its unchanging speed. To explain this phenomenon, different hypotheses were advanced. Possibly, the ether was moving with the Earth, or the devices were changing shape when moving, compensating for the effect, but all of them seemed contrived and did not solve the problem. Faced with this contradiction, physicists realized classical physics was not working. A new paradigm was needed. This fresh idea was born in the mind of a completely unknown clerk of the Swiss Patent Office, Albert Einstein. In the year 1905, he published an article with a simple title, On the Electrodynamics of Moving Bodies, where, without mentioning complex experiments, relying only on logic and thought experiments, he proposed a radical view of the nature of light and motion. But what if light always moves at the same speed for any observer, regardless of how fast he himself is moving? What if this is not a peculiarity but a basic law of the universe? It was from this simplest assumption that Einstein derived the special theory of relativity, and its results turned out to be astonishing. If light does not change speed, regardless of the movement of the source or the observer, then space and time lose their status as absolute quantities and become relative. Time for different people flows differently depending on their speed. Distances in the direction of travel shrink, and events that seem to be happening simultaneously to one observer may happen at different times for another. This seemed unthinkable, but mathematics confirmed it perfectly. Most importantly, the theory states that the speed of light is not just the speed of waves, it is a fundamental limit. Nothing in the universe is able to move faster than light. The reason is not technical obstacles, but the very structure of space and time. The speed of light is embedded in the fabric of reality as an unchanging constant. Why exactly 300,000 kilometers per second? Why not 1 million or 10? The answer lies in the system of our measurements, meter and second, which were invented by us. If we had chosen other units, the number would change, but the main thing is not the number, but the very fact of the existence of a limiting speed of propagation of interactions. In modern physics, the speed of light is often taken as one. They say, here is the maximum speed at which cause can follow effect. Everything else always goes more slowly. But where does this limit come from? Why does the universe impose such a restriction? To understand, we need to look at what happens to a moving object as it approaches the speed of light. That is where a real paradox begins. Reality ceases to obey the usual laws, and the closer you get to the limit, the stranger the world appears. First of all, the mass of the object begins to increase. And this is not about weight on a scale, but about the effect on inertia, resistance to acceleration. Imagine, it is easy to speed up a cart, but much harder to accelerate a truck. The greater the mass, the more effort is required to change the speed. As an object moves toward the speed of light, its inertial mass approaches infinity. Classical physics by Newton teaches, with constant force, an object accelerates uniformly. The longer the force acts, the higher the speed. But in the theory of relativity, the picture is different. At first, the object gains speed as expected, but as it nears the light limit, everything changes. You apply the same effort, but the increase in speed becomes smaller and smaller. All the energy goes not into acceleration, but into an increase of mass. With each step, the object becomes heavier and more inert. So, at a speed equal to 90% the speed of light, the mass already doubles compared to rest. At 99%, it increases by 7 times, at 99.9% by 22 times. The closer you are to the light barrier, the more rapidly the mass grows. At the mark of 99.99% of the speed of light, the mass increases by 70 times. What will happen if you try to reach the speed of light itself? The mass will become infinity. This means that further acceleration would require an infinite amount of energy, which simply does not exist in the universe. The energy of our universe is limited, therefore it is impossible to exceed the speed of light. This is not just an engineering difficulty, it is a fundamental limitation embedded in the nature of the laws of physics. The speed of light is always a receding boundary, an asymptote, which one can approach but never reach. Each next percent of speed requires more and more energy. The last percent consumes as much as all the previous 99% combined. The final 0.1% consumes just as much again, and so on without end. We fall into a trap of diminishing returns. Infinite investments of energy bring ever smaller increases in speed, which eventually approaches zero. That is exactly why light moves at the speed of light. Photons, particles of light, have no rest mass, so for them this speed is not a limit, but the only possible mode of motion. They cannot slow down. From the moment of birth, a photon instantly moves at the ultimate speed and does not change it afterwards. This is the natural state for massless particles. And all masses, any objects with mass, are doomed to remain below this level. The greater the mass, the harder it is to accelerate. However, mass is only one side of the coin. At speeds close to the speed of light, another unusual thing happens. Time itself begins to flow differently. For an object rushing at almost the speed of light, time slows down. And this is not a perception illusion, but an objective physical fact, confirmed by numerous experiments. Imagine two twins. One stays on Earth, the other sets off on a spaceflight, reaching a speed close to the speed of light and then returns. For the traveler, only a few years will pass, and he will age only by this short period. But upon returning home, he will see that the twin on Earth has turned into an old man. During this time, decades have passed there. Why does this happen? Time for the cosmonaut flowed more slowly. His biological functions, thoughts, and sensations slowed down, but he did not notice this. For him, everything went at a normal pace. The slowing of time is noticeable only from the outside. This is not a philosophical invention, but a real effect, proven in practice. Particles that arise in the upper layers of the atmosphere as a result of collisions of cosmic rays with air atoms live a very short time. For example, muons decay in fractions of milliseconds, during which time, even when moving at the speed of light, they would be able to cover only a few hundred meters. However, the atmosphere has a thickness of tens of kilometers, which means that muons should not have been able to reach the surface of the Earth. Yet they do reach it. But the answer lies in the fact that muons move almost at the speed of light, because of which, for them, the passage of time slows down. From our point of view, their life lasts much longer than their own lifetime, allowing them to cover tens of kilometers and reach detectors on the ground. But if we look from the position of the muons themselves, time for them flows as usual, a millionth fraction of a second, but distances are perceived as much shorter. The atmosphere seems not of enormous thickness, but only a few hundred meters. Space contracts in the direction of movement. These are two sides of the same coin. For the external observer, the slowing of time operates, and for the moving object, the contraction of space. Time and space are inextricably connected and form a single whole called spacetime, which is distorted during motion. Imagine that an object tries to reach the speed of light. The slowing of time becomes infinite, time stops. For an object moving at the speed of light, time completely ceases to flow. A photon, for example, considering its journey from the sun to the Earth, experiences this journey as an instant. From birth to absorption, for this is a single event. It does not experience the passage of time at all and exists outside of it. Because of this, objects with mass cannot reach the speed of light. For them, this would mean a complete freeze of time and all processes, which is incompatible with life. But there is a phenomenon even more amazing and little known. When a body accelerates, approaching the speed of light, the surrounding vacuum begins to behave differently. Emptiness ceases to be empty, it turns into something else. A barrier, a wall, a flame. This phenomenon is known as the Unruh effect, one of the extraordinary predictions of quantum field theory, discovered in 1976 by the Canadian physicist William Unruh. He proved that an observer in a state of acceleration sees the vacuum not as empty, but as filled with radiation, as if with hot gas, particles, and heat, whereas a stationary observer sees an ordinary, cold vacuum. How is this possible? The issue lies in the quantum nature of the vacuum. It is not an absolute emptiness, but a seething sea of virtual particles that constantly appear and disappear in pairs, a particle and an antiparticle. They are born from nothing, live a brief instant, and annihilate each other, vanishing. These fluctuations are not an abstraction, but real processes that produce significant effects, for example, the Casimir effect. Usually, we do not see them because they average out and the vacuum appears empty and cold to us, but for an accelerated observer, the situation changes dramatically. Vacuum is traditionally associated with absolute zero temperature. However, for an observer experiencing acceleration, the situation changes abruptly. Acceleration seems to create its own event horizon, a region behind the object from which no signal can ever reach it. This horizon becomes an unreachable boundary, affecting the quantum fluctuations of the vacuum. Virtual particles appearing at the edge of this horizon lose the opportunity for annihilation. One particle of the pair travels beyond the horizon, while the other remains, and for the accelerating observer, they turn into real particles. These particles are perceived as radiation with a certain temperature, and the stronger the acceleration, the higher this temperature. For ordinary accelerations from everyday life, the effect is almost unnoticeable. At an acceleration of 10 meters per second squared, the Unruh temperature is negligible, about 10 to the power of negative 20 Kelvin, absolutely unnoticeable. But for an object striving towards the speed of light, the required acceleration becomes extremely high, and the Unruh temperature begins to play a significant role. The vacuum turns into a real wall of fire. Imagine a spaceship trying to approach the speed of light. At first, everything goes as usual. Engines work, the ship gains speed. But with each new fraction of approach to the speed of light, acceleration becomes more difficult. Mass increases, new acceleration requires more and more energy, the engines operate at their limit. At this moment, the crew notices a strange glow directly ahead. The vacuum starts to glow and emit heat, not due to resistance from the interstellar medium, but because the vacuum itself has turned into a furnace of fire. This is the Unruh effect, which appears as rising vacuum temperature with increasing acceleration. The closer the speed is to that of light, the steeper the acceleration that is needed to overcome the final barrier. Acceleration grows exponentially, and the temperature of the radiation grows with it, until when trying to reach the speed of light it becomes infinite. As a result, the vacuum becomes an impassable wall of fire, a powerful barrier that cannot be crossed. Thus, the universe sets yet another protective limit, clearly showing it is impossible to go any further. Although there is no direct experimental confirmation of the Unruh effect, achieving such colossal accelerations is beyond the capabilities of modern equipment. It is closely related to Hawking radiation. This radiation arises at the event horizons of black holes and indirectly proves the principle of quantum vacuum fluctuations. The Unruh effect is only a mirror reflection of the same phenomenon, only for an observer moving with acceleration. Two phenomena are two sides of the same coin. If Hawking radiation is real, then the Unruh effect must also exist. As a result, three physical barriers can be distinguished that the universe raises on the way to exceeding the speed of light. First, the incredible increase in mass, requiring more and more energy up to infinity. Second, the slowing of time, when processes actually stop. And finally, an unexpected barrier, a wall of fire, turning emptiness into an insurmountable furnace. But that is not all. There is yet another, more fundamental boundary, the principle of causality. According to it, the cause must occur before the effect. First you press the trigger, and only then does the bullet fly. First the stone hits the window, and then it breaks. It is this law that becomes the fundamental limitation, not allowing the violation of the natural order of events. The order of events is not just a chain, but a principle strictly limited by the speed of transmission of interactions, signals, information, influence. All these processes cannot exceed the speed of light, otherwise, the sequence of events would depend on the observer's point of view. For one person, the cause could precede the effect, and for another, the reverse, which contradicts the basics of logic. Imagine you send a signal at superquantum speed to a distant planet, and for you, sending and receiving coincide in time. But time is a relative thing. For an observer moving relative to you, these events are no longer simultaneous. The signal reaches the target before it was sent. The effect overtakes the cause. The paradox becomes even sharper if such an observer sends a reply with the same superluminal signal. It arrives to you in the past, before the moment the request was sent. You receive an answer long before you ask the question. This is a causal loop. Information circulates in a temporally closed circuit. The effect generates the cause. A logical paradox arises. The most famous example is the grandfather paradox. You go to the past and eliminate your grandfather before meeting your grandmother. Your parent does not appear, which means you are not born. Then who managed to go to the past and kill the grandfather? An endless logical circle arises. The special theory of relativity prohibits such situations not because of a physical law of whim, but because they are incompatible with the mathematical structure of space-time. If the speed of light is the limit, causal loops are excluded. Signals propagate through the so-called light cone. The future is located inside the cone, the vertex of which is your current position. Any event you can influence will pass inside this cone, and anything that can influence you is in the past cone. These regions do not overlap. Closing the loop is impossible. Causality is preserved. But what will happen if this light barrier is broken? The cone will break apart, and you will be able to go beyond causally determined zones, get into an area not connected to your past, and return back in time. The logic of causes and effects breaks down, paradoxes arise, and the universe loses its stable structure. Events can occur without a cause, and causality becomes conditional. This is chaos, the destruction of the foundations of reality. Physicists searched for loopholes. Is it possible that there exist unusual configurations of space-time where faster-than-light motion does not lead to paradoxes? Could there be special paths that allow breaking the light barrier without losing causality? All searches yielded one answer: no. Any guesses lead to either causality breaking down or the need for physically impossible conditions, negative energy, exotic matter, or infinite resources. The universe guards its boundaries. The speed of light is not just a limit but a kind of protective barrier. Without it, reality itself could not be sustained. Let us imagine for a moment that such a speed does not exist, and information interactions spread instantly. At first glance, this sounds tempting. No delays, instant response to commands, communication without obstacles over any distance, interstellar flights are just a matter of technology. However, a deeper look is needed. In the absence of an upper speed limit, relativity disappears. Time becomes absolute, space is fixed, and all observers agree everything happens synchronously. At first look, this seems convenient, but then electromagnetic fields cease to function. Maxwell's equations require a finite speed of wave propagation. Without it, light and electromagnetic interactions are simply impossible. Electrons would not remain in atoms, which would disintegrate, and material existence would lose its foundation. Even if we imagine that physics somehow miraculously adapted to an infinite speed of light, the problem of causality would still remain unsolved. For one observer, a signal may be instantaneous, but for another, moving relative to the first, it would not be. This would destroy the sequence of events, lead to the appearance of causal loops and paradoxes, and dissolve the very logic of the universe. The speed of light is not an obstacle, but a fundamental cornerstone of the universe. It supports causality, the skeleton of time and space, electromagnetic forces, and the structure of matter. It is not just a technical barrier that can be bypassed by an ingenious trick, but a basic rule without which physical reality loses its meaning. Many dislike the word impossible, especially when speaking about space. Our world is enormous. The distances to the stars are measured in light years. The nearest star is 4 light years away, the center of the galaxy is more than 27,000 light years, and the Andromeda galaxy is almost 2.5 million light years away. Even when moving at the speed of light, the journey would take centuries, millennia, millions of years. And physically, we are not able to reach this speed. Modern technologies allow only a small fraction of the speed of light, making interstellar travel virtually impossible from the perspective of time. And so the question arises, is it possible to bypass the prohibition, not by breaking the speed of light, but by breaking through it in some other way? Physicists have proposed various theories. One of the most famous is wormholes, or Einstein-Rosen bridges. These hypothetical tunnels in the space-time continuum could connect 2 distant points. Imagine space as a flat piece of paper where 2 points are located far from each other. To get from one to the other, you need to cover the entire distance along the surface. But if you fold the sheet and pierce it at the point of intersection, a corridor appears, shortening the path between them. By passing through such a tunnel, you instantly arrive at the remote point, overcoming enormous distances almost without spending time. You have not exceeded the speed of light, you have simply found a shorter path. Within the framework of the general theory of relativity, wormholes are mathematically permissible. These objects were first described by Einstein and Rosen in the 1930s, however, they are associated with serious difficulties. First, wormholes are inherently unstable and instantly collapse. To keep them open, exotic matter with negative energy density is necessary. Such matter does not attract, but on the contrary, repels, counteracting gravity and preventing the tunnel from closing. Is it really possible? There is a suggestion that it is. In quantum physics, for example, the Casimir effect demonstrates the presence of negative vacuum energy between 2 closely spaced metal plates. This phenomenon, although small, shows that negative energy is theoretically achievable and possibly can be increased to scales sufficient to stabilize wormholes. A technologically advanced civilization could create and maintain such a structure. Nevertheless, even if it is possible to create a stable wormhole, another mystery arises. These tunnels can function as time machines. If one entrance remains stationary and the other is accelerated to a speed close to the speed of light, and then returned back, time shifts between the entrances will cause a paradox. From one entrance you can get to the past through the other. This creates a classic causal loop, the grandfather paradox, which causes serious doubts. The universe, according to Stephen Hawking, protects causality. Quantum effects should destroy the wormhole the moment it becomes a time machine. Vacuum fluctuations will grow without limits, tearing the tunnel apart. This is called the chronology protection conjecture. It guarantees that causality is preserved. And even if we imagine that stable wormholes exist, the mystery of their detection remains. Possible natural wormholes, if they exist, are most likely microscopic, quantum objects at the Planck length scale. They are so small that even an elementary particle cannot pass through them. To create a large-scale wormhole, gigantic energy would be required, equivalent to the energy of many stars. A civilization of Kardashev level 3, capable of using the energy of an entire galaxy, could try to do this, but we are still far from such technologies. There is also another way to bypass the light barrier, the warp drive, proposed in 1994 by Mexican physicist Miguel Alcubierre. This concept relies on the curvature of space-time, which is permitted by the general theory of relativity. Mass creates gravity by curving space, and Alcubierre proposed the possibility of creating a bubble of curved space around a spacecraft. Inside this bubble, space-time remains flat, and the ship is at rest relative to it. The outer part of the bubble compresses space in front of itself and expands it behind, thereby moving the ship forward. At the same time, the ship itself does not move in local space, remaining stationary inside the bubble, which allows it to avoid violating the limitations of the speed of light. Nowhere on a local scale can anything exceed the speed of light, but the bubble itself is able to move faster than light relative to distant objects. This sounds like a loophole, but from a mathematical point of view, such a possibility exists. The equations of the general theory of relativity do indeed permit such solutions. However, there are gigantic obstacles in the way. First and foremost, to create such a bubble, exotic matter is needed. Again, negative energy in incredible amounts. Alcubierre found that for a bubble large enough to contain a spacecraft, energy with a mass equal to the masses of many stars would be required, and it is unknown where to obtain it. The second stumbling block is that the ship inside the bubble has no causal connection with the outside world. It cannot control its own movement. How to activate the drive, change course, or stop remains a mystery. The third is radiation. When moving at a speed exceeding the speed of light, the bubble accumulates high-energy particles from interstellar space, which, upon stopping, would be released forward as deadly radiation capable of destroying everything in its path. In this way, the ship turns into a gigantic laser of mass destruction. In recent years, improved versions of warp drives have appeared, requiring significantly less energy. Some scientists have hypothesized that it might suffice to use only ordinary matter in extremely specific conditions, without any exotic matter, but these ideas remain purely speculative. No one knows for certain whether they will work in reality. Even if they do, the technical capabilities of humanity are far from the required level. There are also other directions. For example, quantum teleportation. Quantum entanglement allows the instantaneous transfer of information about a quantum state, but this is not a full-fledged transmission of data, since to obtain the result, a classical communication channel is still required, operating at the speed of light. Therefore, faster-than-light information exchange is impossible. There also exist hypothetical particles, tachyons, which are believed to move faster than light, but if they really exist, they violate causality and create paradoxes. Therefore, most physicists categorically reject their existence. The bottom line is as follows. All known methods to bypass the speed of light either require impossible conditions or contradict the fundamental laws of physics. Light is not just a technical limitation but the boundary of reality itself. Beyond this clear line, the familiar order collapses, and the universe fiercely protects this limit through infinite mass, the stoppage of time, uncontrollable radiation, violation of causality. But why is this boundary so sacred for the cosmos? Why is the speed of light guarded so mercilessly? Let us dive deeper. What are space and time? In Newtonian classical mechanics, they are simply a background on which events unfold. Objects move along this unalterable stage. Time flows evenly and equally for everyone. The stage itself was unchanging. However, the general theory of relativity completely changes this picture. Space and time are not a static stage. Space-time is something dynamic, constantly interacting with matter. matter curves this fabric, and distorted space-time, in turn, affects the motion of matter itself. It is in this interaction that gravity manifests itself. But what is space-time in its essence? What is it made of? This question remains one of the key issues in modern physics. There is a version that space-time is not a basic entity but emerges from simpler elements. Thus, string theory states that on the smallest levels, it represents vibrations of strings. According to another theory, loop quantum gravity, space-time consists of discrete quanta connected in a network, like atoms of space. In any case, the structure of space-time strictly obeys laws. For example, the speed of light is a parameter of this structure, the speed at which disturbances propagate through it. Imagine a stretched fabric. If you pull it in one place, a wave will travel along the entire surface. The speed of this wave depends on the physical properties of the fabric, its elasticity, density, and tension. Similarly, the speed of light is determined by the characteristics of the space-time fabric itself, its structure and elasticity. This speed is finite because the fabric is not perfectly rigid. It has inertia and response time. Why exactly this speed? Why is it not higher or lower? The answer lies in the fundamental constants of nature. The speed of light in vacuum is related to the electric and magnetic permeability of vacuum, parameters that reflect how a field passes through emptiness. These values are connected to other constants: Planck's constant, electron charge, gravitational constant. Together they form a single order. If one of the constants changes, the entire system is disrupted. The universe is calibrated with amazing precision. If the speed of light or other constants were different, nature, organs of life, and stars would look completely different. Perhaps life would not have appeared at all. There are hypotheses that at the very beginning of the universe the speed of light could have been different, but so far no measurement confirms this. The speed of light remains unchanged, both today and billions of years ago, at any point in the universe. Now let us look at the philosophical meaning of this value. The speed of light limit does not simply restrict movement. It regulates cause and effect relationships and shapes time itself. The past is already fixed and can influence us, while the future remains open, created under our influence. These two regions are separated by the light cone. Everything outside this cone is not causally related to us. It is beyond the past and the future, in a space of uncertainty and relativity of simultaneity. The universe is by no means a predictable machine with a pre-written scenario. There is room for freedom of choice within it. Processes in different corners of the cosmos proceed separately from each other until their light signals intersect. Such a structure gives rise to the possibility of complex interaction. Chains of causes and effects diverge in different directions, information spreads and intertwines. It is in this that complexity, life, and consciousness are born. The speed of light is not a limitation, but a shield protecting us from chaos. If light spread instantaneously, all events in the universe would be connected with no delay, and causal relationships would become universal and global. Any change at one point would immediately affect everything else, depriving the world of local autonomy and individuality. Everything would turn into one huge, unpredictable mixture, where it would be impossible to distinguish separate elements. Under such conditions, complexity would not arise, life would not appear. Thanks to the finite speed of light, separate local zones are formed, which can develop according to their own rules until they intersect with external influence. And it is precisely this that becomes the basis for organization, structure, and life. Let us return to the initial idea. The speed of light is often perceived as an insurmountable barrier, a wall, a limit. However, it is more correct to regard it as a foundation, a supporting pillar. Thanks to it, everything else exists. Without this cornerstone, structure, logic, time, causality, matter, and life would not have arisen. This limit is not an obstacle but the basis on which reality is built. Surpassing the speed of light is impossible not because of mistakes or technological shortcomings, but because that very question simply does not make sense. It is the same as asking, what is north of the North Pole? There is no further direction there. It is a boundary. In just the same way, the speed of light is the limit of the real world. Faster is not possible. Beyond that there is nothing, only emptiness and non-existence. However, we should not think that this means forever remaining on Earth and giving up the dream of the stars. There are other paths. One of them is relativistic ships capable of reaching a significant fraction of the speed of light, 90%, 99%, and more. At such speeds, time for the crew slows down. What for them is years of travel, for Earth turns into decades or centuries. This is the price that will have to be paid. Cosmonauts become time travelers and arrive in the future, while their home remains in the past. This is a difficult but real choice, technically difficult, but not forbidden by the laws of physics. Another option is generation ships, giant vessels on which entire communities live, sent on a journey for many centuries. Those who set out on the journey will never see the goal, but their descendants and grandchildren will build a new world on a distant planet. This method is slow but achievable. The third path is anabiosis, to freeze the crew and awaken them only upon arrival. Centuries will pass unnoticed for those who travel. For now, this is science fiction, but it fits within the framework of physical laws, so it is possible that someday it will become reality. The fourth way is not to travel ourselves at all, but to transmit information. Probes with artificial intelligence and clear instructions are sent into space in order to create a new civilization there. The probe arrives, builds infrastructure, creates people from genetic material, or starts new life based on artificial intelligence. The question of what to consider a continuation of humanity enters the realm of philosophy, but this is entirely possible and does not require overcoming the speed of light. The fifth path is to accept reality. Space is infinitely vast, and we are only its tiny part. Stars are beautiful lights in the night sky, but not places for travel. Choosing to study one's own planet and the nearest solar system is not a feat, but sound pragmatism. But there is also another view. What if the speed of light limit is not a prison, but a form of protection? Perhaps the huge distances between stars exist precisely to separate civilizations from each other, to force them to develop independently, to prevent galactic wars, and to avoid catastrophes that could destroy all systems at once. The centers of interstellar space are not emptiness, but a kind of barrier, a special isolation and protection. Perhaps this is a blessing. We live in an era when humanity is just beginning to master space. We have already been to the moon, sent probes to the planets, and look into distant galaxies with telescopes. We have realized that the universe is boundless. There are billions of stars in the sky and trillions of planets. Life may exist somewhere, possibly even developed civilizations, but the path to them is closed. They are not able to reach us, nor are we able to reach them. The speed of light separates us, and this is a blessing, because if there were no space, if the universe were as easy to access as the road between cities, space would have long ago turned into a battlefield. Civilizations would collide, compete, and destroy each other. Earth's history is full of wars and conquests, and what could happen on a galactic level is left only to be imagined. The speed of light gives us the necessary time for development, for maturing, for understanding ourselves, before meeting anyone else. Perhaps this is the wise intent of the universe. Perhaps it is not an accident, but the physical laws are arranged so that life could arise and flourish, but not destroy itself prematurely. The speed of light is part of this protective system. It sets boundaries, complicates space, makes us reflect before acting, and teaches patience. It shows that not everything is subject to our will, that there are immutable laws which cannot be violated. This is an important lesson, because if we had unlimited freedom, we would have destroyed ourselves long ago. Limitations are not a prison, but a framework within which creativity and life unfold. Without them comes chaos. The speed of light is a basic framework of the universe, its fundamental principle. It sets the boundaries of what is possible, forms structure, makes reality tangible. We started with the question of why it is not possible to exceed the speed of light. Now, the answer is clear. The issue is not lack of technology or energy, but that it contradicts the very essence of reality. The speed of light is not just a speed of motion, but the speed of causality, the speed of existence. Nothing can happen faster, because what happens spreads through time, and time is directly connected to this value. The speed of light and time are inseparably linked. To try to surpass light is to try to outrun time, but time cannot accelerate beyond itself. Such an endeavor is pure contradiction to logic. The universe guards this limit with all its might. Mass approaches infinity, time freezes, vacuum turns to flame, causality collapses. Everything seems to say, stop, the path is closed beyond this point. This is not just a physical barrier of stone or metal, but a wall constructed from logic itself, from the essence of existence. On the other side, there is neither emptiness nor darkness. There is simply the absence of being, the disappearance of any reality. We exist on this side, in a world of laws, where causes give birth to effects, where the past forms the present, and the present influences the future, where matter holds atoms together, stars shine, planets rotate, life appears, and consciousness comes to understand itself. All this is possible only thanks to that wall, that limit, the speed of light. We can see in it a barrier, chains preventing us from conquering the universe. We might be angry, dream of bypassing paths, invent technologies to destroy the prohibition. But there is another view, to see in this wall a foundation, a support upon which the whole world stands. Without it, there would be neither us, nor the universe, nor reality itself. Instead of limitation, a protection deserving of gratitude. The speed of light is not just a number, not only 300,000 kilometers per second. It is a fundamental law, a load-bearing wall of the cosmos, that which makes the universe a universe and gives reality weight. We live, think, love, and create thanks to the structure of space-time, upheld by this limit. These are not chains, this is a home, the boundaries within which life is possible, a shield against chaos, the border between being and non-being. And we are fortunate to be on this side, in a world of order, meaning, and beauty, a world where we exist. When we look at the stars and realize we cannot reach them, this may sadden us. But there is also joy. The stars shine, their light reaches us across time and space, bringing information about distant worlds. We are able to study the universe while remaining on our own planet, because the physical laws are the same everywhere. Atoms on distant planets are just like the ones here. We are part of a single universe, one reality, one whole. The speed of light does not separate us, it connects us, reminding us, we are all subject to the same laws, we all live within the same home. And this is wonderful, for these boundaries are not a prison, but a home. This is reality, everything we have and everything we truly need. The speed of light is not just a limit, it is a boundary beyond which light, information, and any connection disappear. There is no time, no space, no causality there. Absolute non-existence reigns there. We, on the other hand, live inside this light, in a space filled with meaning and causality, where life exists. And we should value this barrier. Without it there would be neither us nor anything at all. Behind it lies not ordinary darkness, but a complete absence of existence and reality. The speed of light is our protection from this void. It creates an island where everything is possible, from atoms and stars to consciousness, love, creativity, and knowledge. This is possible thanks to structure, which depends on the speed of light as a solid foundation on which everything rests. We should think of it not as a barrier, but as a guardian and key pillar of our world. When we look at the starry sky, we do not see the present, but the past. Light travels to us through centuries. Some stars have already gone out, but their light still reaches us, preserving their memory. The limitation of the speed of light gives us history, the direction of time, the separation of the past and the future. If light traveled instantly, everything would happen at the same time. There would be no change, no development, and no us. The finite speed of light creates time and formats the narrative of the universe, from the Big Bang and simple particles to life and human consciousness. We are the product of 14 billion years of evolution, from primitive atoms to civilization, and this long journey is possible only thanks to the stable laws of physics and the unchanging speed of light, the load-bearing support of reality. Next time you look at the light, remember, before you are not just photons, but messengers of the structure of the universe, waves of space-time, the expression of the fundamental limits of the universe. Light connects us to the cosmos, showing that the laws far away are the same as they are here, proving the unity of reality and the possibility of understanding the world, because it has order and meaning, which rest precisely upon the speed of light. The wall of light is not a barrier, but a foundation, a load-bearing support of all reality, a basis that makes everything else possible. It is a shield from chaos, separating being and non-being, a boundary beyond which there is nothing. We exist inside this wall, in a world of light, meaning, and life. And for this we should be grateful, for without it we would not exist at all. Only emptiness and darkness, the absence of everything. The speed of light is not just a physical constant, but a philosophical symbol. It reminds us, our reality obeys laws. Not everything is allowed, it has limits, structure, meaning, and beauty. The speed of light is the voice of the cosmos, which says, here are the rules, here are the boundaries. Inside them, freedom and infinite possibilities. But you cannot cross these boundaries, you cannot break the structure, for without it, there is only emptiness. Inside the rules, everything is possible, outside, nothing. We listen to this voice, study the laws, and learn the structure of the universe. We build civilizations, create art, love, and live, and all this is thanks to the existence of boundaries, laws, structure, the speed of light. This invisible wall is the support of the universe, the foundation of existence. It must be respected, understood, and we must live in harmony with it, for it is our home and shield, that which makes us and the world real, gives meaning, beauty, and true love. Everything holds on this fundamental boundary that protects from chaos. When you see light, it is not just brightness, it is the very structure of reality, the voice of the universe, the bearing wall that protects from non-existence. Cherish this light, live within these boundaries. This is not a prison, but our home, and in this lies the strength and beauty of existence.